Hello everyone, welcome to the channel. Today we'll be doing questions based on reverse chain rule for integration, that is questions from NCERT exercise 7.2. Okay, so let's begin. So the first question is e raised to integration 2x plus 3 dx. So we will be applying this formula. Integration of e raised to x dx is e raised to x plus c. Now, if you see this variable and this function are different. We don't have x there. So we'll have to substitute. Let's put 2x plus 3 as t. On differentiating with respect to x, we get 2 as it is. Derivative of x is 1, 3 is 0 and derivative of t is dt by dx. So we finally have this. This can further be written as dx is equal to half dt, because if we are going to change this variable to t, we'll also have to change dx, because that shows what is the variable, right? So if x is the variable, it should be dx. If t is a variable, it should be dt. So let's put these things here. So this becomes e raised to 2x plus 3, we will write as t, and what is our dx? Half dt. Now half is a constant. Let's put it outside the integration. Integration of e raised to t dt, like going along with this, is half e raised to t plus. Now what is our t? 2x plus 3. So put it back and that's your answer. Now if the same question was to be done directly instead of substitution, if we would apply direct integration. So going with this formula, it would become e raised to 2x plus 3, but we have to differentiate 2x plus 3 in the denominator, because our variable here is x and this is 2x plus 3. So let's see what we get. That's the same as this. But this is the reverse chain rule of integration, which can be applied only when in place of x you have ax plus b. Linear variation is allowed. Only then, for any function. If instead of x we have ax plus b, we can directly do this. In derivative, we used to take into d by dx of the function. In here, we have to take it as division. Okay, and only ax plus b is allowed. Fine? Okay. So now we have to integrate the function root of ax plus b dx. We'll be applying this formula, but as you see, this is x and this is ax plus b. So either we go with substitution, and if we do it directly, we have to differentiate ax plus b in the denominator. We'll see both the methods. So first let's go with substitution. Ax plus b is t, because that's the change from the formula, or rather it is, you can also say, a composite function, linear raised to half. So we're going to take this as t. Now differentiate it with respect to x. Derivative of x is 1, b is 0 and t is dt by dx. So we have a is dt by dx, or we can say dx is 1 by dt. Let's put all of this here, that is integration of ax plus b is t, dx is 1 by a dt. Once again, 1 by a constant, and this can be written as t raised to half. Apply the formula. T raised to half plus 1 upon half plus 1. And let's put back the value of t. So this becomes 2 by 3a, taking this 2 here, and this is ax plus b raised to 3 by 2. Fine. This is the integration of root of ax plus b dx. Now, if we were to do this directly, we would have written it as ax plus b raised to half using the formula. It becomes ax plus b raised to 3 by 2 upon 3 by 2. And yes, You have to differentiate this ax plus b in the denominator because it is not x, it is a linear change in x. So differentiate it in the denominator, which is a as it is, derivative of x is 1 and b is 0. So that's the same thing. If you take 2 here, it is exactly the same. So it can be done this way or with substitution. We know the direct integration of sec square x is tan x plus c. So over here, if we directly apply the formula, it's going to become 10 7 minus 4x plus c. But as we see, this 7 minus 4x and x are not exactly the same. You have to differentiate it in the denominator. So it becomes tan of 7 minus 4x upon derivative of 7 is 0 and minus 4x is minus 4. So that's the direct integration where we are applying the reverse chain rule. If you go with substitution, let's say substitute, as we see, this is a composite function, sec square, instead of x you have linear. So let's put it as t, and now what is the derivative of 7? 0 minus 4. Instead of writing this as 1, I'll write it as dx because later also we'll be bringing dx on the left side, so I'll better write here. So what is dx? Minus 1 by 4 dt. So when we put this in the integration, it will become sec square t and minus 1 by 4 dt. So minus 1 by 4 is constant. Let's put it outside. It is sec square t dt. Of course, integration is tan t. And yes, replace t back. That's what we have over here. So can be done by both the methods, by substitution or direct. Okay, so let's see another question. So now if you see this question, this is not a linear function like earlier we had ax plus b raised to half or sec square 7 minus 4x where within the function we had linear function. Now this is of course a composite function because it is log x the whole square. It is log x and a polynomial function. So in such cases where you have composite function, we need to go with substitution. So let's substitute. Which function do we have here as composite? Log x. So let's try and put log x as t. And as you keep on doing, you'll also notice that the derivative is visible here, like log x derivative is 1 by x. So it will become dt. So in most of the questions, you will be having the function and along with that you will have the derivative. So as you see here, if we are going to put log x as t, this is going to become t square and dx upon x is going to become dt. So applying the formula x raised to n, we have t cube by 3 because it is 2 plus 1, that is t cube by 3 plus c. And yes, of course, put back the value of t. So whenever we see a composite function, we are going to look for the substitution. Now let's see here. As you can see, we have sin x and sine of cos x. This is a composite function. So let's try to put this as t and see if we can make it integrable. So we are going to substitute cos x as t. The derivative being minus sin x dx is dt. So we have sin x dx. Sin x dx is minus dt. So in place of sin x dx, we are going to write minus dt. So I'll put the negative sign outside and dt. Sine of cos x. Now what is cos x? T. So it becomes sin t. Integration of sine is minus cos t plus c. And so this becomes cos of, put back the value of t, cos of cos x plus c. So you will have to see now in this both questions which we took the function inside. Like suppose if it is f composite g of x, then we have taken g as t in both the cases. Like we had in the earlier one log x squared. So we took log x as t. Now we have sine of cos x. We took cos x as t. Sometimes we'll have to take the whole function, but we'll have to see if we have its derivative along with. Now in this case, we had only the derivative of cos x, so we put it as t. We'll come across the questions and I'll let you know that. Okay. Let's go to the next. In here, we have log x raised to m. This is also a composite function. So let's substitute log x as t. Right? Because composite function is there, we think of substitution, and the function here is log x raised to m. So you have to either take it log x as t, otherwise log x raised to m as t, depending on which function is there along with. In this case, we have 1 upon x dx. As you can see, that's the derivative of log x, so we have to take log x as t. So let's put these things here. 1 upon x and dx will become dt, and this is t raised to m over here, log x. This can also be written as t raised to minus m. So apply the formula of x raised to n and you will have t raised to minus m plus 1 upon minus m plus 1. And yes, the last step should be to put back the value of t, whatever you have substituted. Yeah, over to the next one. This is x square upon 2 plus 3x cube whole cube. This is a composite function, so obviously we are going to look for if we can put this as t. Let's substitute 2 plus 3x cube as t. Whichever is a composite function, think of putting that as t. If you get the derivative along with, well and good. Let's see. The derivative of 2 is 0 and this is so x square dx becomes 1 by 9 dt. Let's put this here. 1 by 9, that is for x square dx, 1 by 9 dt, and this thing is rt, so it becomes t cube in the denominator. So the next step will be taking this as t raised to minus 3 and we will integrate it using the formula. Okay, so let's do that. Minus 3 plus 1 and yes, put the value of t now. You want, you can put this in the denominator, that would be your final answer. Hope you have understood so far. Do like the video, share it, and yes, subscribe to the channel. Now let's see in this question which one is the composite function. As we see, it is e raised to x square, exponential and quadratic. So first of all, we'll write it as e raised to minus x square and x dx. Now, minus x square is the term which is in place of x. According to the formula, it should be x dx. Here it is minus x square dx. So let's put it as t and c. The derivative of x square is 2x. The negative sign stays there. Okay. Derivative of x square is 2x dx and that of dt is t is dt. So fine, let's put it here. Okay, but that is x dx. So this will become minus half dt. Minus x square is t. X dx is minus half dt. So minus half is a constant. Let's pull it outside. Minus half integration e raised to t dt. What's integration of e raised to t? E raised to t plus c. So if you must have noticed, in integration, the formulas are very important. If you know the formulas, then you can do the questions well. Let's move to the next question. You have e raised to tan inverse x upon 1 plus x square. So we see this is a composite function once again. So we are going to take tan inverse x as t, and we also know that the derivative is 1 upon 1 plus x square. Okay, and because the variable is x, we have written dx dt. That's already here. So it is integration e raised to t dt. Now, integration of e raised to t dt is e raised to t plus c. Put the value of t back, and that's your answer. Let's go to the next now. It is cos root x upon root x. Once again, composite function with root x. So let's put root x as t. That is x raised to half. Now, the derivative of x raised to half is half x raised to half minus 1. N x raised to n minus 1. Simplifying this, you will get 1 upon 2 root x dx is dt, or otherwise, because in the integration you see, we don't have 2, so we have to take this 2 on the other side. So this 1 upon root x dx is going to become 2 dt. This is cos t root x substitution. Okay, so 2 goes out, integration of cos t, sine, and plus c. What is t? Root x, and that brings you to the answer. Okay, so in this video, we have taken very simple questions about substitution or the reverse chain rule. In the next video, we'll be taking up more questions of the same exercise. So see you in the next video.